Hello and welcome to this lecture on measures of center or measures of central tendency. In this lecture we're going to be going over the different types of measures of center, including mean, median, and mode, their importance in statistics, how to calculate and interpret them, and we're also going to look at the strengths and weaknesses of these measures of center and when to use them. Measures of center or central tendency are values that describe what is average or typical of a distribution. And there are three measures of center that we are going to discuss today. The first is the mode. The mode is the category or score with the highest frequency or percentage in the distribution. The median is the value or score that divides the distribution into two equal parts. It is essentially the middle value. Mean is the most common measure of center. It's the one you are most familiar with. It is also called the average, and it is the arithmetic average obtained by adding up all the scores and dividing by the number of scores. Let's dig into these a little bit more. The mode is not really a calculation. It's the most frequent category or value in our distribution. If we were looking at a nominal or ordinal level measure, it is the category with the highest frequency. So when you're looking at those frequency tables, like we talked about last week, it is the category with the highest frequency. So you can look down the list in that table and see the one with the highest frequency or highest percentage, and that is going to be our mode. If we are looking at interval or ratio level measures, it is the value or score that occurs most frequently in the data set. When a distribution has two categories or values that have the highest frequency, then that distribution is what we call bimodal, and both categories or values are considered the mode. The median is a measure of center for ordinal, interval, and ratio level data. It does not work for nominal level data, and you'll see why in just a moment. It is the middle value in the distribution and divides the distribution into two equal halves. This only works if we can rank or order our cases. So if we remember about nominal level measures, you cannot rank or order nominal level measurements, and so a median does not work. You cannot have a median in nominal level measures. To find the median, first arrange the responses in order from lowest to highest or highest to lowest. Either way is fine. The median case can be found by adding 1 to the total number of cases, or n, and then dividing by 2. So the formula would be n plus 1 divided by 2, and that's going to be our median case. This means for an odd number of cases, you will end up with the middle case. Whatever case you end on, that value is going to be the median. For an even number of cases, it gets a little bit trickier. You will not have a single middle case. Instead, you will average the values for the two middle cases. Averaging the two middle scores is not valid with ordinal level measures. Again, because the difference between each level in an ordinal level measurement is not valid. There's no meaning in that distance. So when we have even number of cases, we can only average the score for interval and ratio level data, not for ordinal. In the case where we have an even number of cases and we have ordinal level measures, we will just simply state that the median falls between these two cases. We do not actually say that the median is one category or another. We just say it falls between these two categories in an ordinal data set. Alright, last we have the mean. The mean is the most common of these measures of center that we've talked about today, and it only works for interval or ratio level data. To calculate the mean, you add up all the values of the cases in the dataset and then divide by the number of cases in the dataset. So in this equation we have y bar, which is the mean for y, is going to be equal to the sum of all the scores in y divided by n, which is the number of observations or cases. So again, y is the mean, y is the raw score for the variable, so each case gets a score, y is that score. The sum of y is the sum of all the scores in our data set, and n is the total number of observations or cases. We have to be careful with means because means are particularly sensitive to outliers or extremely high or low values. So when we have cases where we have income, for example, where we might have people who are making millions of dollars a year and some people are making uh, tens of thousands of dollars a year, we have to be very careful because that mean is going to be what we call skewed. And we'll get into that a little bit more later in this lecture. So let's practice finding these measures of center. So for finding the mode, when we're talking about nominal or ordinal level data, and we're looking at a frequency table, it's very easy. Looking at this frequency table here, we can see that we have region of birth, and they've given us South and East Asia, Mexico, Europe or Canada, Caribbean, Central America, South America, Middle East, Sub-Saharan Africa, and all/other, everybody else. Now to find the mode in this example, we simply need to look for the region with the highest frequency. And in this case, they've ordered it for us already. And we can see that South and East Asia has the highest frequency here. Now, I want to be clear here. This does not mean that the mode is 11,731,584. No, that's just the frequency. The mode is actually South and East Asia. This means that the modal region of birth for people who are foreign-born in the United States in 2016 is South and East Asia. So in this case, the category is the mode, not this frequency. So the category that is modal is South and East Asia. South and East Asia is the mode. So let's practice finding the mode when we have interval or ratio level data. Again, if we have a table like this, our best option is to simply find the category or value that occurs most often in the data set, which again we can look at frequency here. And here we can see that again 0 children occurs 13 times in the data set and is therefore the most frequent and is therefore the mode. So in this case, our mode is simply 0. 0 children is our mode for this data set. Again, I want to bring attention to the fact that 13 is not the mode. 13 here is not the mode. Our mode is actually 0. Alright, so let's talk about finding the median in an ordinal level measure. So here we have a variable called political view, and we have it ordered from extremely liberal to extremely conservative. Now, remember, finding the median, we're looking for the middle value or the middle case. And our formula for finding that is as follows. We have our n plus 1 divided by 2. And in this case, our n is 1011. So we're going to have 1011 plus 1 divided by 2 is going to equal 556. Now this 556 is our median case. It is our middle case. In order to find that middle value, we're going to need to find that middle case. And so again, because we have this frequency table here, the thing we can do is start adding up these frequencies. And thankfully, they've already done this in this table. And so we're looking for the 556th case. It's not going to fall under extremely liberal because that only includes the first 61 cases. It's not going to fall under liberal because that includes only the first 194 cases. Remember, 133 plus 61, 194. Slightly liberal, liberal, and extremely liberal only account for 324 of our cases. However, when we jump to moderate, we find that we have 735 cases. Whoops. We have 735 cases. And so 735 cases fall between extremely liberal and moderate, which means that our 556th case is going to fall between extremely liberal and moderate. And we already discussed it doesn't fall under extremely liberal, liberal, or slightly liberal. No, that 556 case is going to fall under moderate. So we can say that our median value here, or our median category here, is going to be moderate. And again, I'm doing that by first calculating the median case and then figuring out, when I have all my cases in order, where that median case is going to fall. And given that they've already given me this cumulative percentage and cumulative frequency, I can tell that that 50th percentile case or that 556th case is going to fall in the moderate, because 556 is greater than 324 but less than 735. Alright, so let's look at this example now. Again, in this example, we are looking at interval and ratio level data, and we're going to try to find the median. We have 40 cases total, so again we're going to use our formula of 40 plus 1 divided by 2 is going to be equal to 20.5. So now we're going to try to find that 20th and 21st case. Now how we can do that here is we can again add up the frequencies listed here. So this first here is 13 cases in the 0, and we add 9 and we get 22. So this 22 is the cumulative percent, or cumulative frequency. And so what we know here is that the 20th and 21st case for this data set is going to be 1. And so we can average the ones. It doesn't really make any difference, but what we find is that the median value in this data set is 1. One child is the median value here. And again, I'm doing that by calculating the middle values and then using this frequency table to find out where those what category or value those median cases fall under, and then using that to calculate my median. And in this case, the median number of children in this data set is 1. Alright, so let's talk about finding the mean. The mean in this case is going to be the sum of all the values in the data divided by the number of cases in the data. So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different cases, and we have their incarceration rates or values over here. So in this case, what we're going to do is we're going to add up all these values and divide by 10 the number of cases. So let's go ahead and do that. And I've already done this for you off screen, so hopefully it's correct, but we're going to essentially end up with 430 plus 761 plus 601 plus 325 plus 442 plus 484 plus 578 plus 676, 438, and then 530. And we're going to divide all of that by 2, but first let's sum it up. So after we've summed it all up, we find that our total here is going to be 5,265. That's our sum of all of our cases, or the scores for all our cases. Now we need to divide that by 10. And luckily, dividing by 10 is pretty easy here. We're going to end up with a mean of 526.5. Now I want to highlight here that this 526.5 might be a good measure of center, but it also might be affected by the fact that we have a number of pretty strong outliers in this data set, including this 761, and then also the 676. These outliers might, what we would term, skew this data set. And so it might present some error into that mean, meaning that that mean is not going to be perhaps the best measure of center for this data set. But we'll talk about that in just a moment. So I mentioned skewedness earlier on, so let's talk about it. Distributions for interval and ratio level variables can be described by the shape of their distribution. So a typical distribution will what we call symmetrical or normal. And in these symmetrical or normal distributions, our mean, median, and mode are all the same. So our mean is going to be equal to our median, which is going to be equal to our mode. However, these sorts of distributions are fairly rare. Usually we have what are called skewed distributions. And there's two ways our distribution can be skewed. It can be negatively skewed, which means we have some really extreme outlier low values in our data set. And what that'll mean is that skewedness, that those negative outliers, will draw our mean down. So our mean will decrease compared to our median and our mode, as you can see here in our negatively skewed distribution. To the left side are the low numbers, and to the right side are the higher numbers. We can also have something that is called positive skew, and this is when we have some extreme high value scores in our data set, and again this will draw our mean higher, and therefore our mean will not be equal to our median and our mode, as you can see here. And these aren't something to be super concerned about, but something to keep in mind when we talk about which measure of center we should use. Alright, that is all for this lecture. Thank you everyone. I hope you have a good day, and I'll talk to you next time.